Hi, my name is Hayden Hall, and I will be examining a problem from Chapter 15 that pertains to the manipulation of chemical reactions with a given equilibrium constant. The problem I will work through, number 27, is stated as follows. This reaction has an equilibrium constant of Kp equals 2.26 times 10 to the fourth at 298 Kelvin. The reaction we will look at is CO plus 2H2 at equilibrium with CH3OH. For A, B, and C below, we will calculate Kp for each reaction and predict whether reactants or products will be favored at equilibrium. In order to solve this problem, it is important to remember the following: that Kp equals products over reactants. In this case, if Kp is less than 1, then the reaction favors the reactants. If Kp is greater than 1, then the reaction favors the products. Also, when in reverse, you would take the inverse of Kp forward. This would give you Kp reverse equals 1 over Kp forward. Furthermore, when multiplied, in this case by 1/2 in the generic equation A plus B at equilibrium with 2C, you get a new equilibrium expression that Kp 1/2 equals C divided by A to the 1/2 times B to the 1/2. Notice that the 2 here in front of the C is cancelled out by the multiplication of 1/2. And lastly, Kp does not have units because molarity or atmospheres of concentrations or partial pressures respectively will be cancelled out during the division of products over reactants. To begin solving this problem, we need to remember that our original reaction is CO plus 2H2 at equilibrium with CH3OH. Part A gives us CH3OH at equilibrium with CO plus 2H2. What we notice here is that this is the inverse of the original reaction and that it is not multiplied by any factors. Kp equals 2.26 times 10 to the 4. So we take the inverse to find Kp reverse, which equals 1 over 2.26 times 10 to the fourth, which gives us a value of 4.42 times 10 to the negative 5. Since Kp is less than 1, then the reaction favors the reactants. In Part B, we are given 1/2 CO plus H2 at equilibrium with 1/2 CH3OH. This is the same as multiplying the entire reaction by 1/2, as you can notice that the 2 in front of H2 in the original reaction has been cancelled out. What we notice here is that the reaction is in a forward direction and has been multiplied by 1/2. Here we will raise Kp to the power that is the same as the value of the coefficient multiplying the reaction. So Kp 1/2 equals 2.26 times 10 to the fourth, all raised to the 1/2, which gives us a value of 1.50 times 10 to the 2. Since Kp is greater than 1, then the reaction will favor the products. In Part C, we have 2 CH3OH at equilibrium with 2 CO plus 4H2. What we notice here is that the reaction is going in the reverse direction and is being multiplied by 2. The steps of Part A and Part B will be combined in that we must take the inverse of Kp forward and raise the value of Kp to the second power. This will give us Kp reverse multiplied by 2 equals 1 over 2.26 times 10 raised to the 4, all raised to the 2, which will give us a value of 1.96 times 10 raised to the negative 9. Since Kp is less than 1, then the reaction will favor the reactants. In summation, problem 27 of chapter 15 revolved around giving us an initial Kp value and then expected us to calculate Kp for each reaction when the reaction was driven in the reverse direction or when the reaction was multiplied by certain coefficient values. We could then use this value to determine whether the reaction favored reactants or products based on whether Kp was greater than or less than 1. Thank you for watching.